Hi everybody. So this question says that the terminal arm of angle theta in standard position contains the point negative b to b where b is positive. Now they tell us that b is positive just so that I get that, hey, the x coordinate must be negative. It can't be like the negative of a negative, which would be positive. This is going to be a negative number and the y value is positive. And then it asks us for the exact value of sine. Okay, well, first of all, I know that the x coordinate is negative. I know that the y coordinate is positive, so I know it's going to look like this. It's going to be in the second quadrant. Here's my theta. This is negative b. This is 2b. Now, I want to figure out what sine is. I know that sine, I'll put this over here, sine is going to be y over r. Well, what I need is r. So x squared plus y squared is equal to r squared. There's the Pythagorean theorem, which in this case will be negative b squared plus 2b squared equals r squared. So this is going to be b squared plus 4b squared equals r squared. In other words, 5b squared is r squared. Okay? And so from there, I know that the square root of 5b squared is r. Now, not plus or minus, because the r is defined to be positive all the time. And I can take the square root of b squared, and that's going to actually give me root 5 times b, just b. Now, let's take a quick look here. Sine of theta is y over r. Well, the y coordinate in this case was 2b, and we've just discovered that r is root 5b. Well, the b's will cancel. I'm left with 2 over root 5. That might actually be an acceptable answer. However, I suspect that you're probably going to get asked to rationalize this, in which case this becomes 2 root 5 over 5. And so that would be the sine of an angle that goes through a point that looks like that.